Hari Om. Hello everyone, I am Shri Jyoti. Welcome back to my channel. Today's video is of class 10 mathematics chapter 1 real numbers. In class 9 we have already studied about rational numbers and irrational numbers. So here we will study real numbers. Okay, real numbers, set of real numbers is the union of rational numbers and the irrational numbers. That is, real number is any number excluding complex numbers, that is imaginary numbers. That is, real number is any number excluding imaginary numbers. So here real numbers can be defined as the union of rational numbers and irrational numbers. Look at this classification of real numbers. Real numbers constitute the rational numbers and irrational numbers. That is, set of real numbers is the union of rational numbers and irrational numbers. Rational numbers consist of non-integers and integers. Non-integers means fractions. Okay. Integers with non-integers, that is fractions, is the set of rational numbers. Integers consist of negative numbers, whole numbers. Right? Set of whole numbers with negative numbers is the set of integers. Whole numbers consist of 0 and natural numbers. Set of natural numbers with 0 is the set of whole numbers. So here we can say real numbers, set of real numbers is the union of natural numbers, whole numbers, integers, rational numbers, irrational numbers. Okay, and real numbers can be denoted as capital R. So in this chapter, first we will study a theorem, that is fundamental theorem of arithmetic. So before that we should go through factors, prime numbers and composite numbers. So what is a factor? We have already studied about this. Factors. What is a factor? A number divides any other number exactly, that is without leaving a remainder. Then the number which divides is called a factor of the number which has been divided. Right? For example, 24. See, this 24 can be written as 6 into 4. Right? So here we say 6 is a factor of 24, 4 is a factor of 24. Right? So here next is prime numbers and composite numbers. So prime numbers and composite numbers. What is a prime number? See, a number, if a number has no factors other than 1 and itself, then the number is called prime number. Otherwise it is composite numbers. Okay. So here for example, let's take example for prime numbers. We know that what is the smallest prime number? 2, right? 2 is a smallest prime number. 2 is a prime number because 2 can be written as only 2 into 1. That is, its factors 1 and 2. That is 1 and itself. 3 is a prime number. Right? 5 is a prime number. 7, 11. Right? Because see, 11 can be written as 11 into 1. So factors of 11 are 1 and 11, 1 and itself. Right? So 3, 5, 7, 11, etc. are prime numbers. What about composite numbers? That is, if a number has factors other than 1 and itself, okay, then the number is called composite numbers. For example, 4, 6, 8, 12, etc. Okay, see, for example, 12 can be written as 3 into 4. Okay, so 3 and 4 are factors of 12. Okay, that is, this 12 has factors other than 1 and itself. 12 has factors 3 and 4 other than 1 and itself. Therefore, 12 is a composite number. Okay, now let's go through the theorem, fundamental theorem of arithmetic. This theorem says that any composite number can be expressed as product of prime numbers. It's very important. Fundamental theorem of arithmetic says that any composite number can be expressed as, that is, composite number is equal to product of prime numbers. Okay, that is any composite number can be expressed as product of prime numbers. Let's take one example. Let's take a composite number, any composite number 6. Okay, see here we know that 6 can be written as 2 and 3 are prime numbers, right? So here 6 can be written as product of two prime numbers 2 and 3. Next, one more example, 8. See, 8 is equal to 2 into 4. Here 2 is not a prime number. So here we can write 2 into 2. That is 2 cube. Okay. So here this theorem says that any composite number can be expressed as product of prime numbers. Okay. Now here how to write a composite number 230 as a product of prime numbers. Let's find the prime factors. Okay. See, 230, it is to find the prime factors. See, since it is an even number, then you just start from 2. Okay. Divided by 2. Because 2 is the smallest prime number. Okay. 2 ones are 2 ones are. Okay. Then here it is an even number and end with 5. Therefore, take 5. Even number 5. Okay. 5 is a prime number. So 5 2s are 10. 5 is a 15. Okay. Then after that, see 23 itself a prime number. Okay, because 23 has no factors other than 1 and itself. Okay, so here this 230 is a composite number. This can be written as 2 into 5 into 23. That is product of prime factors. Product of prime numbers. So this composite number 230 can be expressed as product of prime numbers 2, 5, 23. That is 2 into 5 into 23. Look at the first question, very important question. Explain why 3 into 5 into 7 plus 7 is a composite number. We know that composite number has factors other than 1 and itself, right? And by the fundamental theorem of arithmetic, we know that composite numbers can be expressed as the product of prime factors, right? So first of all, let's write the given number. 3 into 5 into 7 plus 7. You can calculate directly or see here there are two terms, right? First term, second term. In both the terms 7 is common. So we can take 7 into here 3 into 5 plus 1. Right? We have taken 7 outside. That is equal to 7 into 3, 5, 15. 15 plus 1, 16. That is equal to 7 into 16 can be written as 2 into 2 into 2 into 2. That is 2 raised to 4. 7 into 2 raised to 4. 2's are prime numbers. 7 is a prime number. Right? So here it is clear that this number has factors 7 and 2. Okay? This given number has factors 7 and 2 other than 1 and itself, right? Therefore, this number is a composite number. That is, given number has factors other than 1 and itself. Therefore, it is a composite number. Look at the second question. Check whether 4 raised to n, where n is a natural number, can end with the digit 0 for any natural number n. See here, we have to check whether 4 raised to n can end with 0 or not, right? And we know that any number ends with 0 is divisible by both 2 and 5, right? You can take any example. That is, any number ends with 0 is divisible by both 2 and 5. Okay, that is, any number ends with 0 is a composite number, and by according to the fundamental theorem of arithmetic, it can be expressed as the all prime factors, right? So let's take one example. Any number ends with 0, 40. Okay, 40 can be written as 8 into 5, that is equal to 8 is 2 into 2 into 2 into 5 are the prime factors. Okay, we have written 40 as the product of prime factors. See, there are 2 and both 2 and 5 are here, right? Therefore, here we can say 40 is divisible by both 2 and 5, right? So here, if 4 raised to n is divisible by both 2 and 5, then we can say 4 raised to n can end with 0. Okay, for any natural number n. Now let's take 4 raised to n can be written as 4 can be written as 2 into 2, right? So 2 into 2 whole raised to n. 2 into 2 is 2 square. 2 square whole raised to n, 2 raised to 2n. That is, 2 raised to 2n means 2 into 2 into 2 into etc. 2n times. So there is only one prime factor, that is 2. So according to the fundamental theorem of arithmetic, there is no other prime factor in the factorization of 4 raised to n. That is, 5 is not a factor of 4 raised to n, right? That is, 5 is not a factor, prime factor of 4 raised to n. There is no 5 here, right? Therefore, 5 is not a factor of 4 raised to n. What does it mean? That is, 4 raised to n is not divisible by 5. That is, 4 raised to n is not divisible by 5. It is divisible by 2 but not 5. Okay. Therefore, here we can say 4 raised to n cannot end with 0 for any natural number n. Okay, that is, according to the fundamental theorem of arithmetic, there is no prime factor in the factorization of 4 raised to n. That is, 5 is not a prime factor of 4 raised to n. That is, 5 is not a factor of 4 raised to n. That means 4 raised to n is not divisible by 5. Okay, if any number ends with 0, if any number ends with 0 is divisible by 5. Okay, therefore 4 raised to n is not divisible by 5. Hence 4 raised to n cannot end with the 0. Okay, digit 0 for any natural number n. See, next we will study how to find HCF and LCM of given numbers. Okay, see, what is HCF? Highest common factor, and LCM, least common multiple. Okay, so here how to find HCF and LCM by prime factorization method. Okay, directly let's go to the with the examples. Okay, so here, for example, find the HCF of two numbers 120 and 140. Okay, here first of all we have to write the prime factorization. That is, these are the composite numbers, right? So first of all we have to write these numbers as the product of prime factors. Okay, that is 120. Let's find the prime factors. 120, 2s are 260s are, okay, 230, okay, 3, 10, then 2, 5, okay, over. All these are prime numbers. Okay, then after that 140, 2, 70, 7, 10, 2, 5. We have got all the prime factors. So 120 can be written as product of prime factors 2 into how many 2's? 3's. 3 2's, right? 3 times. 1, 2, 3 into 3 into 5. That is 2 cube into 3 into 5. Now 140 is equal to 2 square into 5 into 7. Right? Okay. Now let's see how to find HCF and LCM of these two numbers. See, HCF, it is nothing but highest common factors, right? That is, here you have to write, see, what is common here? Common factors 2, 5, right? 2 and 5. After that, see how to write. See, you have to write, it is the common factors, okay? Therefore, here you have to write the smallest power of each common factors involved in this number. Okay, that is smallest power. See, 2 is the common factor and what is the smallest power? 2. Therefore, 2 raised to 2. Okay, into next 3, 5, yes, 5 is common, right? So, 5. 7 is not common, 3 is not common. Okay, therefore 2 raised to 2 into 5 is the highest common factor, HCF, right? That is 4 into 5, 20. 20 is the HCF of given two numbers 120 and 140. So remember, you have to write here smallest power of each common factor. Common factor, it's very important. Smallest power of each common factor involved in this number. Okay, that is HCF. Next is LCM. LCM is the least common multiple. That is a number, that is smallest number which is the multiple of given numbers. That is which is divisible by both numbers. Okay, so here how to write a LCM? By prime factorization method. That is, see, these are the prime factors. Okay, so here you have to write, it is the multiple, okay, common multiple. Therefore here you have to consider greatest power, okay, greatest power of each factors involved in this number. Okay, no need to check common factors, greatest power of each factors. Okay, see, what are the factors? 2, 3, 5, right? So here we will write, here 2 raised to 3, here 2 raised to 2. Therefore we will take 2 raised to 3. Okay, 2 raised to 3 into 3. Okay, we have to write all the factors here into 5 into, we have already written 5. So into 7, because it is the least common multiple. Okay, that is a smallest number which is divisible by both numbers. Okay. So here LCM is equal to, we have to write greatest power of each factors, okay, each factors involved in this number. Okay, therefore 2 raised to 3 into 5 into 7 is the LCM. That is equal to 8 into 5, 40, 40 into 3 into 7, that is 120 into 7, that is 840. So LCM is 840. See, next question, very important question, CBSE 2008 question. Write the HCF of smallest composite number and the smallest prime number. See, here we have to find the HCF of two numbers. What are the two numbers? Smallest composite number. See, what is the smallest composite number? Is it 1? Not 1, right? So 1 is neither prime nor composite, right? So 2 is prime number, 3 is a prime number, 4 is a composite number. So first composite number, that is the smallest composite number, is 4. Smallest composite number is 4. And the smallest prime number is 2. Okay. Now here we have to find the HCF of 2 and 4. Okay. HCF of 2 and 4. Now here 2 can be written as 2 into 1. Right. And 4 can be written as 2 into 2. Right. Now what is HCF? Here 2 raised to 1, here 2 raised to 2. Okay. See, as I mentioned before, see how to write the HCF? That is smallest power of each common factor involved in this number. That is, see, smallest power. Here it is 2 raised to 1 and here it is 2 raised to 2, right? 2 raised to 2. So, smallest power, that is 2, right? So, here HCF of 2 and 4 is 2. Look at the next question, very important question, CBSE 2010 question, okay. See here, the question is, two positive integers a and b can be written as a is equal to x cube y square and b is equal to xy cube. Xy are the prime numbers. Find the LCM of a and b. Very simple. See here, we have to find the LCM of a and b. Right? See here it is given a can be written as x cube y square. Here x and y are prime numbers. Okay. So here a can be written as product of prime factors x and y. That is x into x into x, y into y into y. Sorry, x into x into x into y into y. Right? Y 2 times. Okay. So here and b is equal to x into y cube. Okay. How to find the LCM? See, LCM of a and b. See, as I mentioned before, how to write LCM of two numbers? By the prime factorization method. See here, that is greatest power of each factors involved in the numbers. Okay. So here what are the factors? X and y. Right? X and y. And greatest power. Okay. You have to write. That is LCM of a and b is here x cube. Here x raised to 1. So you have to write x cube. Here greatest power. Okay. In HCF smallest power. Okay. Here x cube x. So x cube. X cube into. And next factor is y. Here y square, here y cube. So you have to write y cube, okay, into y cube. Therefore, LCM of a and b is x cube, y cube. Now, what about HCF? Here, HCF is not asked, but what is HCF? HCF is HCF of AB. That is HCF of AB. You have to write smallest power of each common factors. Here common factors are x and y, right? So common factors x and y and smallest power. See here x cube, here x raised to 1. So smallest power is 1. Therefore x and next factor is common factor is y. So here y square, here y cube, smallest power is 2. That is y square. So x y square is HCF. Okay, HCF of a and b is x into y square. LCM of a and b is x cube into y cube. It's very important question. Next we are going through relation between numbers on their HCF and LCM. Here let's take any two numbers for any positive integers a and b, then HCF of a and b into LCM of a and b is equal to product of two numbers a and b. Okay, a into b. That is, see here we can write HCF of A and B is equal to A into B divided by LCM of A and B. Right? LCM of A and B is equal to A into B divided by HCF of A and B. If LCM and two numbers are given, then we can find HCF. And if two numbers and HCF are given, then we can find LCM. Look at the first question. The HCF of two numbers A and B is 5 and their LCM is 200. Find the product of A and B. See, what is our formula? That is relation between HCF and LCM, and the numbers is HCF of AB into LCM of AB is equal to A into B. Right? Here we have to find, here HCF and LCM of AB are given. We have to find A into B, product of A and B, that is A into B. Okay, so A into B is equal to HCF is 5 into LCM is 200, that is 1000. So, product of A and B is 1000. Look at the next question. If the HCF of 35 and 45 is 5, LCM of 35 and 45 is 63 into A, then find the value of A. Our equation HCF of 35 and 45 into LCM of 35 and 45 is equal to 35 into 45. That is the formula, right? That is LCM of A into B, A and B is equal to, LCM of A and B into HCF of A and B is equal to A into B, right? So here it is given HCF and LCM. HCF of 35 and 45 is 5 into LCM of 35 and 45 is 63 into A, that is equal to 35 into 45. Here we have to find the value of A, right? So A is equal to, take this 5 into 63 right side. So 35 into 45, it will be in the denominator, right? So 5 into 63. Okay. That is equal to, cancel it. So 5 ones are 5 sevens are. Okay. 7 ones are 7 nines are. Right. So 9 fives are 45. So 5 is the value of A.